on this one, I'm just going to point out a couple points. Let's pretend this line segment is part of a function, right? So we'll call this f of x. And this point here, remember you start at the origin, which is 0, 0, and I go 1, 2, 3, 4, 5, 6, negative 6. In other words, I'm going 6 units in the negative x direction. And then I go up 1, 2, 3, 4, 5, 6, 6 units in the positive y direction, right? You remember that? Going up is positive, going to the right is positive, going down is negative, and going to the left is negative. So we always start from the origin, do x directions first, then y directions. And then over here, we have the point negative 2, because I start at the origin, I go 1, 2, and then I go down 1, 2, 3, 4, 5. So I go negative 2 in the x direction and then negative 5 in the y direction. Now for the inverse, remember for the inverse, we are swapping our x and y, right? So x has an input value, it spits out the y, but for the inverse, the y becomes the x and the x becomes the y. So that means I'm going to have two new points. So I'm going to have these points on my graph. Actually, let me change the color on that. So if I were to graph the inverse of this line segment, the inverse points would be the same, but I'm swapping the x and y. So if I look at this, I'm going to swap the x and y. In other words, there should be a point 6, comma, negative 6 on my inverse, right? And I'm just swapping the x and y. And then there should be a point negative 5, comma, negative 2. All I'm doing is I'm taking the x and y's and then I'm swapping them. Now, if I graph that, first point, I'm going to go 6 in the positive x direction, then go down 6 in the negative y direction. And that's my point 6, comma, negative 6. And then I'm going to go negative 5 in the x direction and then down 2 in the negative y direction. And then I'm going to draw a line between those. Now that is the inverse function line segment. But there's an interesting property between the function when you graph it and the inverse function. What you probably don't recognize is that if I were to draw a function that went through this diagonal line, and we were to label this g of x equals x, the inverse function and the function are going to be symmetrical about the diagonal. So what I'm saying is that f inverse and f of x are symmetrical about the diagonal g of x equals x. Every single time. Every single time that I graph a function and I graph its inverse, it'll be symmetrical. Now, if you don't know what that fancy word symmetrical means, think of it as a mirror. It's like I took this thing and I did a mirror reflection across this blue line as a mirror. This is exactly symmetrical to the right-hand side. This side of the mirror looks exactly like this side of the mirror. So if I were to hold a mirror at an angle, the stuff on this side of the mirror is identical to this side of the mirror. Does that make sense? Okay.